Morning, class. It's Sir Capistrana again. And for today, we will be actually talking about isomers. As you may have remembered on our past video regarding the reaction mechanisms or reactions of alkanes and cycloalkanes, we encountered a word called isomers when we talk about monohalogenation of alkanes in which in monohalogenation, we may experience different types of products depending on the halogen that we will be using for the halogenation in the presence of UV light and or heat. So in that, we will be tackling this word actually or this concept called isomers. By isomers, these are actually compounds that have same molecular formula but differ in structure. So basically, we have two general types of isomer. We have the structural or constitutional isomers, which differs only in connectivity or bonding of atoms, and also, we have the stereochemical, which are compounds with same connectivity of atoms, but differ in orientation of atoms in space. So, stereochemical deals more on the three-dimensional structure, or think or classify the three-dimensional structure of our compounds. So in that, actually, our discussion last time on our last video regarding organic chemistry, wherein we talk about alkanes, uh, that type of isomer actually falls under what we call structural or constitutional isomers. So in that, for structural isomers, we actually have three types or three other types of isomers. So we have here structural isomers that differs in functional group or what we call functional isomers. Also, we have isomers with same functional groups, but they differ in the position of functional group or what we call positional isomers. And also, we have skeletal isomers wherein they differ in the connectivity uh, uh, of carbon atom. So in that, let's look into this tree. So as you can see here, this type of isomers, or by looking in this type of isomers, we are just focusing on our chemicals or compounds of interest, which are organic chemists or organic compounds, rather. So let's have first the functional isomers. So by definition, functional isomers have different let's say different functional group. So let's take this type of example. Let's say we have this chemical formula C4H no H10 C4H H10 O. Okay. So basically, when we see this type of formula, assume na agad natin or we usually assume that this is an alcohol. But actually, we can have two types of or different types of uh, organic compound here. So one example here is we have C3, CH3, okay, CH2, 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 then we have here our OH. As you can see here, this is our alcohol. If we actually draw this like we usually do in our in past discussion, this will look like this will be the CH3. This will be the CH3, CH2, 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 and we have here our OH. So basically, this is an alcohol. To be specific, this is actually butanol, right? And we have here butane, one, two, three, four, and we have here all, which is actually alcohol. But in some cases, this formula may be written as this. So we have here CH3, and we have here CH2. Then we have here our oxygen. Then we have here our CH2. Then we have here our CH3. If we actually count the number of carbons here, we have here one, two, three, and 4. And also, for the hydrogen, we have here 3 plus 2, that will be 5, plus 2, that will be 7, and plus 3, that will be 10. So basically, these two have the same chemical formula. By chemical formula, we have here the C4H10O. But for this case, we have here an ether because of the oxygen that is bonded to a carbon and another carbon. So basically, this is an ether, and to be specific, we have here our diethyl ether, which actually would look like this. So we have here CH3, CH2, then we have here our oxygen, our CH2, then our CH2. So, as you can see here, we have here different functional groups. For the butanol, which of course we have here the OH, and for the diethyl ether, we have here our oxygen here. So we have here two organic compounds having similar molecular formula, wherein both of them have a molecular formula of C4H10. So meaning to say, these organic compounds are called functional isomers. Butanol is a functional isomer of diethyl ether by having the same molecular formula, but they differ in the connectivity of or bonding of, or they have different functional group. So our next will be our positional isomers. So by positional isomers, they differ in position of the functional group. They have the same functional group, but they differ in the position. So for example, we have here again our C4H10, H10O. So you may think that ayun, alcohol na naman siya, ano? Pwede naman, pwede natin siyang gawing alcohol. For this case, we can actually write this as this formula. So we have here one, two, three, 4, and we have here our oxygen. So that is our butanol. To be exact, that will be our 1 dash butanol. Or in our OH, or the functional group, is not in, that will be on OH on C1, or the first position, or the first carbon. And also we can write that like this. So we have here our butane, or our 4 carbon atoms. So we have one, two, three, 4. Okay. Then we can all actually write the OH here, or position the OH here, wherein we will have here an OH, or a hydroxide, on our C2. Why 2? Because we have here 1, we have here 2. So basically, we have here two alcohols, wherein we have here the one butanol, and also we have here the two butanol. They have the same functional group, but they differ in the position of the functional group. Same as our example last time. So if we have one one methyl butane, right? So by one methyl butane, if we have this one methyl butane monohalogenated by chlorine, it may have chlorine that is bonded to this tertiary carbon. Also, we may also have a chlorine that is bonded to either of these two. Let's say if we have here this chlorine, so have this chlorine, and also it can also happen that the chlorine from our 1-methyl butane will bond to this secondary carbon. So we have here our Cl. Also, it can also happen that no, like if we have our butane there and our methyl, can also happen that the chlorine will bond to this last carbon here. So basically, these four are actually what we call other examples of our positional isomers, in which we have here our 2-chloro, 2-methyl, that is dash, methyl butane. And for this one, we have 1-chloro, okay? Because the chlorine is attached to the first carbon. Then we have 2-methyl, because this will be 1, 2, okay? Then we have here our butane, okay? So for this one, our chlorine is here, so by hierarchy, we'll be taking this chlorine as our functional group, meaning to say the counting will start here on our first carbon here. So we will have here 1, 2, 3, meaning to say we will have 1 chloro, 3-methyl butane, and also for this one, we will be taking again the position of chlorine as our functional group. So the nearest to our functional group is this one. So this will be 1, 2, 3, 4. Meaning to say we will have here 2-chloro, 3-methyl butane. So as you can see here, the position of our functional group, which is chloro, changes. Okay, so from if we map it on our butane, it can happen that its position may be on either of these two because they are interchangeable. Hindi na natin papansinin kung kanino man sa kanilang dalawa. And also, it can happen here in our tertiary carbon, in our secondary carbon here, or our first primary carbon here. So, in that, we have there four isomers of chloromethylbutane, or our uh, chloroisopentane. So, ayun yung pwede nating tingnan when we talk about positional isomers. For positional isomers, the position of the functional group changes. Okay? And for the last structural or constitutional isomer, we have the skeletal isomer. So by skeletal isomer, we are actually been encountering this skeletal isomer when we have and when we talk about the common names of alkanes. So by skeletal isomers, these are uh, these are just compounds that differ in connectivity of their carbon atoms. So one example here actually is our pentane, wherein pentane has a chemical formula of C5H, that will be H12 if I'm not mistaken. So basically, the structure of pentane here can be separated into three types. So we have here our N-pentane. So by N-pentane, that will be 1, 2, 3, 4, 5. That will be our N-pentane, wherein we have here 1 carbon, 2, 3, 4, 5, and we have 3, 5, 7, 9 plus 3, that will be 12 hydrogen atoms. So, kung nalilito kayo sa ganitong itsura, it will be just like this. So, we have there our CH3, which is bonded to our CH2, 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 and we have here our CH3. Those are similar, okay? But when it comes to different, yung iba pang itsura ng ating skeletal isomer when we talk about pentane, we also have what we call isopentane, okay? Wherein we will have this butane and this methyl. So that is our isopentane, or by IUPCA name, that will be our 2 methyl butane. So for this one, we can actually write this as CH3, CH, then we have here our CH3, then we have here our CH2, and our CH3. Okay. So for the last one, a last skeletal isomer of pentane, as you may have remembered, we have our neopentane. So we're in, if we have here our central carbon here, we will have here methyl group, another methyl group here, another methyl group here, and another methyl group here. So we have here 1, 2, 3, 4, 5. Okay? So basically that would look like this. So we have here C, we have here our CH3, we have here our CH3, we have here our CH3, and lastly we have here our CH3. So that is our neopentane, or our 2,2-dimethyl propane. Sulat nga natin mo yan. So this will be just pentane. This will be 2-methyl butane. This will be our 2, not dash. So that will be 2 dash dimethyl propane. So those are our skeletal isomers. As you may see here, all of them has a molecular formula of C5H12, but they differ on how the carbon atoms are attached to each other. Okay. So those are our three structural or constitutional isomers. We have here our functional isomer, wherein we visualize them using this butanol and diethyl ether. Also, we have here our positional isomers, wherein we used our butanol, wherein we have one butanol and two butanol as our positional isomers. Also, we have here our chloropentane, neopentane, wherein we have four different types of isomers for the chloropentane or neopentane. And also, we have here our skeletal isomer, which is in which we use pentane. By pentane, we have C5H12. We visualize normal pentane or N-pentane. We have the isopentane here and also the neopentane, basically pentane, 2-methylbutane, and 2,2-dimethylpropane. That is our structural or constitutional isomers. So next part of the discussion will be on the next video. So bye-bye.